Hi everyone. Today we are going to talk about section 7.2, which is inductive reasoning to find the nth term. So yesterday we looked at inductive reasoning to find a term, so maybe the 10th term or the 12th term. Well, in this section we talk about inductive reasoning to find any number of terms. It could be the thousandth, the millionth, whatever. You find a formula that helps you to reach the nth term by using what you learned from finding a term, any term, the 15th or the 10th term. So if you look here on our screen, and it says, what is the pattern in the diagram below? What is the 10th term? What is the 16th term? Determine an equation for the nth term. Well, in this case, we have number 1, term 2, term 3. And if we go over here, we're making a table of values. We have term, and then we have number of squares. So for term 1, I'll just write this down here, 3, 4. For term 1, we have 1, 2, 3, 4, 5 squares. And for term 2, well, we have 2, 4, 6, 8, 9. We have 9 squares. And for term 3, we have, 3, 6, 9, 12, 13 squares. And so you could say for term 4, well, each of these seems to be going up 4. Right? And this goes up 4. So for term 4, it would probably be 17, wouldn't it? Because it's going to go up 4. So you would have one more here, and one more here, one more here, and one more here. And that's 1, 2, 3, 4 times 4 plus 1 gives you 17. Okay, I'm going to erase this and then show you, oopsie. Do something else here. So we're going to look at this, and so I said, all right, with the table of contents we had 1, 2, 3, 4. And we had 5, 9, 13, and 17. But you could look at this in another way. So suppose that we said, okay, the first one is 5, and so that's 5. We'll just keep it as 5. The second one is 9 because there's one more set of 4 added on. So this you could say would be 5 plus 4. And 3 would be, 5 plus 4 plus another 4, right? Because we keep adding 4 plus 4. And then 17, similarly, would be 5 plus 4 plus 4 plus 4. So if you look at this, the way this is set up, you could say, okay, well, I have 5 here and no 4s, so there's 0 4s, and 1 4 here for the second term, and the third term has 2 4s, and the fourth term has 3 4s. And so you could make a general rule that said, okay, 5 plus 4 times, n minus 1, because if this is 3 4s, but this is the fourth term, so this is 5 plus 4 3 times, but that's the fourth term. And this is 5 plus 4 2 times, but it's the third term. So here we're going to say 5 plus 4 to the n minus 1 will give you any term. So if we go back up here, what's the 10th term? So if you say n equals 10, so 10, so then that means that 5 plus 4 times 9 is going to give you the number for n equals 10. So 4 times 9 is 36, plus 5 is 41. Okay. And then the next one is the 16th term. So for n equals 16, so that's 5 plus 4, and what would this be? So if it's n minus 1, but n is 16, so then you say 15, and that equals 15 times 4 is 60, plus 5 is 65. So there you have it. I'll write this again. So 5 plus 4 to the 1 less of what your n is. Then, and that's your equation. To the nth term equals where's my equals the nth term. Okay, let's go on to the next one. So what is the pattern in the diagram below? I'm going to go back. Oopsie. What happened? Ooh. Draw. What is the pattern in the diagram below? What is the 8th term? What is the 15th term? And then determine an equation for the nth term. Well, let's write it out here again on a table of values. So this is the term, and this is the number of squares. So term 1 what they call step 1, is 2 squares. And step 2, or term 2, is 2 squares plus 4 squares, or equals 6 squares. And step 3 is 3 squares plus 9 squares, which equals 12 squares. So do you see how this is going? So from 2 to 6, you multiply, well, let's see, it's plus 4. And 6 to 12 is plus 6. So 12, so the next one would probably be plus 8. So that's 20. And then 5 would be 30, because it would be plus 10. Is that clear? I think so. But you can do the same sort of chart here as we did above. You can say, well, 1 plus 1 squared. Because this is 1, you could take this in half. So here's 1 plus this is 1 squared. And the only reason I kind of get a hint for that is this is 2 plus 2 squared. And here 3, 12 gives you 3 plus 3 squared. And do you see how it's going here? So this is 2 squared, and this is 2, and this is 3 squared, and this is 3. So you're just adding on n to the formula, basically. So 20 is 4 plus 4 squared, and 25 is 5 plus 5 squared. So then if you wanted to write a formula, so, okay, so what now would be the 8th term? So the 8th term equals, well, if it's the same, 8 plus 8 squared. And the 15th term would be 15 plus 15 squared. Because see, there's always these out here, these outliers, plus the number squared, n squared. So this is equal to the nth term equals n plus n squared. Or that's also n plus 1. Okay. Now remember that because it's going to come up again, and I'll show you where. Okay, so the next example you're going to see is similar to the previous one, but our approach will be a little bit different. So in this case, we have, and I'll start over here with my chart. But if we just step back for a minute and look and see what we have. So in the first term, it's two blocks. In the second term, there's 2, 4, 6 blocks. In the third term, 3, there's 12 blocks. So it looks similar to another example we've done, but let's just set it up here. So this is the term and this is the number of blocks. We'll call it B. So in the first term, we have 2 blocks. In the second term, we have 6 blocks. In the third term, we have 12 blocks. In the fourth, we have 20. And the fifth, we have 30. It looks familiar, doesn't it? Okay, well, there's a number of different ways we could get to 2, but there's got to be a pattern in here someplace. And what I'm looking at actually is if you look, you could see maybe we have a side of 1 block and a side of 2 blocks, which gives us 2. And a side of 2 blocks and a side of 3 blocks, which gives us 6. So let's just try that out. So a side of 1 times 2 gives us 2. And this one is 2 times 3. So 2 times 3. And number 3 is 3 times 4. And number 4 is 4 times 5. And number 5 is 5 times 6. So what can you infer from that? Well, if you want, you could say, okay, term 1 is 2, and that's, you can come to that by saying, okay, it's term 1 times term 2, which is 1 times 2. This one here, see? And this one, 6, well, you could say it's term 2 times term 3. And this one you could say is term 3 times term 4, and so on. And so then, if we have that, then we can say that if we want the 9th term, if we come down here to 9th term, well, the 9th term would be term 9 times term 10. And if we want the 21st term, well, that'll equal term 21 times term 22. So if we want this in a general form, we could say the nth term equals n times n plus 1. Right? So this is n. If we took the case of 6, 6 is the second term, and so if you multiply 2 times 3, you get 6. So that is how we get to the generic n. Now, remember when I did it before, and all right. What is the pattern in the sequence below? Find the 13th term, find the 17th term, predict the nth term. And the sequence is 6, 9, 12, and 15. All right. So I will make a table of values. 1, 2, 3, 4. 2, 3, and 4. And the value is 6, 9, 12, 15. Well, let's look and see what we have here. So the first term is 6. And then to get from 6 to 9, you add 3. And 9 to 12 is 3 again. And 12 to 15 is 3 again. So we could say, if we're doing this systematically, we could say, okay, well, the first one is 6, so that 6 is 6. And the second one is 9, which is 6 plus 3. And the next one is 12, which is 6 plus 3 plus 3. And the next one is 15, which is 6 plus 3 plus 3 plus 3. And now if you look at this, like some that we looked at before, you can count the number of 3's and look at it relative to the term. You could even rewrite this. You could say 6, and then 6 plus 3, and then you could say 6 plus 2 times 3, and then 6 plus 3 times 3, and so on. And so that helps you get very close to the actual formula. So if you want to find the 13th term, well, we know that it's going to be 6 plus some number of 3's. And in this case, there's 3 3's, but we're in the 4th term. So if there's 3 3's and we're in the 4th term, that means it's 1 less than the term. So you could say 6 plus 3, 6 plus 3, and we're looking for the 13th term, so we put times 12, right? And if we want to find the, what I used here, if we want to find the 17th term, well, that would equal 6 plus 3 times 1 less than the term number, so 16. And then finally, if we want an nth term, so we know from all of that below that n equals 6 plus 3 times the n minus 1 term. And that is the nth term. Okay, here's another one. So now this one we're really getting into inductive reasoning, and I have to say, because it's such an interesting example, and it really is, it really is a good example of inductive reasoning. So here we are. So what is the pattern in the sequence below, and what would the nth term be? Well, so this one we're going to just take a swag, because I'm not going to do the systematic method of finding the series or sequence. I'm just going to say, okay, so if we put it in a table of values, and we 1, 2, 3, 4, 5, 6, I don't know how many, 1, 2, 3, 4, 5, 6. Okay, yeah, so this is the term number, and this is the value, and then we do 0, 3, 8, 15, 24, 35. Now, when you look at these numbers, especially relative to these numbers, what do you think? Like what? So 0, 3, 8, 15, 24. I mean, I could look at it in the context of, well, 0 to 3 is 3, and 3 to 8 is 5, and 8 to 15 is 7. Oh, there we go. And 15 to 24 is 9, and 24 to 35 is 11. So we know how much they're increasing by. And it's so we could do that. But the other thing, that if you sort of look back and stand away from it for a second, so if you say, okay, well, what's 2 squared? So if we think about like 2 squared is going to be 4. And 3 squared is going to be 9. And 4 squared is 16. Sometimes I start with not the 1 just because I want to figure out the pattern first, and then I go back and make sure the 1 fits in nicely. But so look at this. So now we have 5 is 25. 6 is 36. And 1 is 1. So we can make an inference that this is something to do with n squared, okay, with the term squared. Because in each case, the term squared gives you a number, 4. And if you happen to subtract 1 from that number, then you get the value. So if we were to write the nth term, so the nth term would be, let's suppose it would be n squared minus 1. And if you say pick number 7, okay, so if you pick 7 times 7 is 49. And so this would be 48. And let's just see if it works. So 11 and 13, let's see. 35 and 13 is 48. So it does work. At least initially. I'm not sure. We can't prove it clear to the end, but I think it is a substantial possibility that it's the right thinking. So this would be this term. Or the nth term would be this formula. Not true. So to show that a statement is not true, it is enough to show only one example that it's not true. You don't need to show 4 or 5 examples, you only need to show one, and that proves that a statement isn't true. So for example, here's every prime number is odd. So is that true? Let's see. So prime numbers, we have 3 and we have 5 and we have 7 and so on. But we also have 2. And 2 is even. So that statement is not true. Here's another one. Every multiple of 20 is divisible by 4. Well, if it's a multiple of 20, it must be divisible by 20. And if it's divisible by 20, then it's divisible by 4 because 20 factors into 4 and 5. And so if it's divisible by 20, it's going to be divisible by 4. So that one's true. The next one, all animals that live in water are fish. Well, there's a lot of fish in the water, but there's also octopuses and, I don't know, all kinds of things. Squid. Yeah, lots and lots of things that live in the water that are not fish. Coral. Oh, animals. A coral's an animal, right? Okay, the opposite of any number is less than the original number. Well, I think this is going to be straightforward in a second. So here's the number, and here's the opposite. So if you have the number 2, say, well, the opposite of that number is minus 2. And that's definitely less than the number. But if the opposite is, or if the number is minus 2, then the opposite is 2. And that's greater than the original number. So we know that that's false. Alrighty, so the homework for tonight is page 253, number 1 to 2 all, 3A and B, 5 to 6, and 7 odd letters. All right, have a great day.